Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using both the PowerBasic console and Windows compilers. Today we will dip our toes into the world of fractals, using simple recursion to draw a tree in a graphics window. While the world of fractals can deliver stunning visuals, the code behind these images can seem daunting. What we will do today is build simple code with recursion as an introduction to the topic. The application we're going to create today will be able to be run in either the PowerBasic console or Windows compilers. This is because we're going to be using a graphics window. So in our code we have PowerBasic set to compile to an exe. At the moment I have debug error turned on, and the one line of code you may not have seen before is the stack command. This is to set the size of the Windows stack. Normally this is set for 1 MB by default. The stack is used when you're calling a subroutine and then returning back to the calling routine. Since we're going to be using recursion, we're going to be calling subroutines recursively again and again. Therefore our stack needs to be a little larger, so I set the stack to be 4 MB. And in case you're running the console application, I've set it to turn the console off, because in this case we don't actually need the console itself. So firstly we will include the Windows API library. And as we're creating a graphics window, we'll need to set the size of that window. So I've created two constants, mapx and mapy. These are going to be the widths and the heights of our graphics window. I'm going to create a user-defined type called startPoint. The purpose of this user-defined type is to store an X and a Y location. I've also set it up to store a Z location, which we won't be using in this video, but we will be using it in future videos. The X and Y location is to store the location at which we wish to start drawing. We'll cover more of that when we get to it in the code. As the purpose of this application is to draw a tree, we're going to create a few global variables. To set the minimum length of a branch in the tree, to store the colour of the tree trunk, and also we'll want leaves at the end of the branches, so we'll store the leaf colour as well. We're also going to have a variable called shortening. The shortening variable will be used to reduce the length of a branch for each iterative call. So now that we have each of those set up, let's go down to the PB main function. Our first task is to create our graphics window. And if we're wanting to put any text on the graphics window, we'll need a font set up as well. So I'm going to create three local variables. One for the handle of the graphics window, one for the handle of a font if we decide to use it, and a third variable to trap a keyboard input. As the graphics window will display on screen, we don't want the user actually closing the graphics window. Although that would in effect close the graphics window, it would not terminate the application, and the application would continue to run in the background. So we're going to set the graphics window up so that the user cannot close it, and we'll have to press a key in the keyboard to terminate the application. So we will first create our graphics window. The graphics window comes with a number of parameters, the X and Y locations that the window is to start at, and the X and Y locations the window is to finish at. And the command populates this hwin variable, which is our Windows handle. And with that Windows handle, we can use the graphic window stabilize function. Setting this will prevent the user from being able to close the graphics window. So the application code will determine when the graphics window is to close. We then use the graphics attach command, giving it three parameters, the Windows handle, 0, and in this case we're giving it the redraw option. The redraw option means that anything we send to the graphics window will not be immediately displayed to the user on screen. It will wait until we do a graphics redraw command. We're setting the graphics scale from 0, 0, which is the top left-hand corner of the graphics window, that's the 0, 0 coordinates, up to the map X and map Y, which we defined earlier. So any coordinates we issue to the graphics window will be between these two sets of X and Y coordinates. I can now set my font, and we're clearing the graphics window and setting the background to be black. Then issuing the graphic redraw command to display the black window to our user. So issuing the randomized timer command will give us as close to a random number generator as we're going to get. Now we're set up to start drawing our tree. So we will create a new function whose job it is to draw one or more trees. And on conclusion of that function, we will redraw the graphics window to let the user see what has been drawn. At this point, the user will be able to see the graphics window, but they will not be able to close the window. So we're going to use the graphics InKey command to wait for the user to press a key in the keyboard. And once that key has been pressed, we will then end the graphics window, close down the font, and end the application. So that's the kernel of the application. What we need to do now is to create our drawTrees function. The purpose of this function will be to set up some basic starting parameters. We're going to create three variables, one for the branch length, one for the starting position, which is a user-defined type for our X and Y coordinates, and one for the start direction. So let's populate these starting parameters. We're first going to set our branch length to 105 pixels. And we're going to set another variable called minimum branch length. This is the length of a branch where we will change the colour of the branch from brown to green. And we're taking this to be the branch length divided by 10 as an integer. And we'll then set our tree trunk colour, which is a basic brown, and our leaf colour to be a basic green. And the shortening value is the value by which we will actually reduce the branch length for each iteration when we're drawing our branch. We then have to decide our X and Y positions for where the trunk will begin on the graphics window. And we'll make that to be the middle of the graphics window and near the bottom of the graphics window. So all this has been in preparation to start drawing our tree. So we'll create a small subroutine whose job it is to draw the tree. It will take three parameters, the branch length, the starting position, and the starting direction. These functions and subroutines so far have been fairly straightforward, merely passing parameters and calling one function or subroutine after another. We're getting close to the point where we're going to start using recursion. So within this drawTree subroutine, we'll first want to draw a trunk, and then we will call our drawBranches routine. So I first want to store the shortening value that's currently in the global, and then we will set our colour to be the colour for the tree trunk. And to keep our code nice and simple, we will create another subroutine whose job it is to draw the trunk of the tree. It will take a mere two parameters, the starting position and the length of the branch. So the draw trunk is not going to be very complicated. We will set the graphics width of our drawing tool to be the length of the branch divided by 3 as an integer. So the width of all our branches is going to be proportional to the length of the branch. So the shorter the branch, the narrower the width. And we will use the graphics line command to draw our line. This will start at the starting positions defined in a user-defined type as X and Y, and it will draw a vertical line for the length of the branch. And then we will amend the Y coordinate to be the Y coordinate minus the branch line. So our user-defined type is then pointing at the end of the trunk. So we try running that application now to see what we get. And there is our trunk. I'm deliberately keeping these graphics quite straightforward so that the code is easy to follow. Up until now, all we've done is we've created a graphics window and we've drawn the trunk. This is the beginning of our tree. What we want to do now is to draw some branches on the tree. So let's now create the routine we're going to call recursively that will draw our branches. To exit the application, just press any key on the keyboard. So after we've drawn the trunk, we next have to draw some branches. So we'll create a draw branches subroutine. It takes in the branch length, takes in the starting position user-defined type, takes in the start direction, and the amount of shortening. So this subroutine is the one we're going to call recursively. So it will take in the 4 parameters we've already mentioned. And we're going to create some local storage. The x-coordinate, the y-coordinate, and the length. So as we're going to draw the first branch coming off the trunk, the first thing to do is to reduce the length of the branch. So very simple, branch length minus the shortening. Now since we're calling this recursively, eventually the point will come where the branch length is effectively 0. So if the branch length is 0, then we've got to the end of the drawing of our tree. So if that's the case, if the branch length is either equal to or less than 0, we know we've got to the end of the tree and we can exit the subroutine. So as we said, the width of the line we want to draw is going to be proportional to the length of the branch. So we will set the graphics width first of all, and we will divide that by 5. We've already set the minimum branch length by which we are actually going to change the colour of our drawing. So we now have to test to see whether this branch length has actually got to that or not. We can use a select statement to quite easily test that. We're testing the branch length. If it's less than or equal to the minimum branch length, then we'll change to using leaf colour. Otherwise, we will continue to use the same colour as we did for the tree trunk. And we're going to create a new user-defined type here based on the start point. We need to work out what the new ending position of the branch is. Because ideally, we want to set 2 branches coming off this trunk. And each time we get to the end of a branch, we will then branch off 2 more. We will create a new user-defined type called newPosition. So we will pass to a new function, getNewPosition, 4 parameters. The start position user-defined type, the new position user-defined type, the current branch length, and the direction we wish to go. These will have 2 values, one for left and one for right. So having got this new position, we can store the existing position in long X and long Y. Because our starting position is from where we start drawing, and the new position is where we end drawing. We'll create this new function in a moment, but let's just follow this through to its logical conclusion in this routine. So having determined where we're drawing to and from, we can then use the graphics line command to perform the drawing. And as I said, this simply takes the x and y coordinates as the starting of the line, and the x and y coordinates as the ending of the line. The first from the start position, and the second from the new position. And having drawn the line, we now have to save these new positions into the start position, so that the next line will have a starting position at the end of this one we have just drawn. We can use the prefix command to save a little bit of typing. So the start position is equal to the x and y coordinates of the new position. So before we go any further, let's create this new function, the getNewPosition. The purpose of this function is to work out where the new position of our line is going to be. There's 2 ways this function can be called, either to go left or right. So we need to work out an angle. If we kept all the angles exactly the same, then the tree would look quite artificial. We want it to look a little more organic. So we're going to create a local variable called longAngle, and we're going to use the random command to give us an angle between 5 and 75 degrees. Having got that angle, we also know the length of the branch, and we can use a little bit of trigonometry to work out where this will end up. So we're going to be using the cosine and sine commands in Power Basic to generate this information. However, these two commands take radians rather than degrees as their parameter. So we need to convert the degrees to radians. An easy way to do that is to use a macro. So we'll create a macro called degrees to radians. It takes a single parameter, which is our degrees, and it will multiply that by a constant to give us our radians. Macros are very useful for this kind of purpose. So we'll create two local variables, x and y, and we will calculate what these are using the cosine and sine commands, using our macro for degrees to radians. So the random value calculated up here is going to be populated in here. And we want the absolute value of x and y. So these are the new coordinates of the end of our line. As I said, this particular routine can be called with a direction of either left or right. So what we're doing now is we're determining the direction and we're setting an adjustment. This adjustment is going to be used to multiply by the x coordinate. The y coordinate will always be going up the screen, but the x coordinate could go to the left or it could go to the right. So now that we have that, we can actually now generate the new position. And we can populate in our user-defined type the new position by taking the starting position and subtracting the long x multiplied by our adjustment and subtracting the long y. So if the direction is set for right, we would then move to the right hand side. If it's left, then we will move to the left hand side. So let's try running that code now and see what we get. You will see we now have the trunk and we now have a left hand branch. So that only draws the one branch. But what we're going to do now in the draw branches subroutine is we're going to call the routine recursively. So at the end of the code in that subroutine, we're going to call it once more. It takes exactly the same parameters, and as it calls that subroutine again, it will pass all those parameters down, they will be calculated, and it will be drawn on screen. So if we try running that now, you'll see we get a branch running all the way to the very end, and the very last branch drawn is drawn in green. This draws the entire branch from trunk right to the tip of the branch. We need to go further than that. We need to actually draw the right hand branch. That way when we get to the fork, when one branch ends, we will have two branches coming off it, and this will happen at each conjuncture. So let's look to see how we can do that in the code. Before we call the draw branches routine recursively, let's work out the right hand branch. This is going to use the stored positions of our variables, so we're resetting the starting position to long x and long y. We will then do exactly the same as we did before and determine the width of the branch, because as you remember, the width of the branch has been reducing right the way up to the tip of the branch. We're now going back to work out the right hand branch. And of course we'll need to work out the new position just as we did before. So we'll make a call to the get new position, passing the start and new position user-defined types, and we will draw the graphics line. And having done that, we will save the new positions in our start new position user-defined type. So by adding this extra piece of code, calling this time using the right as the direction parameter, if we try running the code now, we'll see we're getting the right hand branch. So in order to get both branches showing, we need to call this routine recursively after the first one. So there are now two recursive calls in here. We generate the locations of the left hand, then call it recursively, and then we generate the locations of the right hand and call it recursively. So if we run the code now, you'll see that our application is now drawing a tree. At each conjunction, when it splits into two, it will generate a direction which is random, and it will then go on to the next conjunction when the two more will be generated, and we end up with a tree. The only thing we need to add at the end is something perhaps to draw the leaves on the tree. So we will do that next. In our Draw Branches subroutine, we've already worked out when we get to the end of a branch. And in here, we want to draw something that looks a bit like a leaf. We can quite easily simulate this using the Graphics Ellipse command. This can be used to draw ellipses or circles. So since we know the X and the Y coordinates that we have completed drawing the branch at, this is where the leaf needs to be drawn. Using the Graphics Ellipse command allows us to draw a leaf based on these coordinates. So we're merely taking 6 away from the X position and 4 from the Y position to start the ellipse, and a height of +6. We're using the leaf colour for the border of the leaf and leaf colour for the fill of the leaf. The 0 at the end means we're going to be using solid fill. So we try running that code now. We'll see we now have simulated leaves on our tree. So with very little code, we have generated something that does appear certainly tree-like. It's not a textured or 3D rendered image, however, it does actually tell us how this kind of code will work. If we try running the application again, we will get a tree which is not exactly the same, as we're using some random routines to generate it, but we do end up with things that do basically look tree-like. And it's using a very simple recursive routine to perform this task. So this has been a very brief introduction to the world of fractals and recursion. Hopefully you have found this interesting, but that's it for today. Thank you for watching.